Okay, we're back, and we're now ready to take the derivative of this equation, this Pythagorean theorem equation. We know the derivative of this constant is going to be 0, so we're not even going to worry about that. We have to use the chain rule here. Ooh, it looks like fun. So chain rule, derivative of the outside, evaluated at the inside, times the derivative of the inside, which is the derivative of this with respect to t. So it's going to be 1 dx dt, plus the derivative of this is 1 dy dt. And then over here, we're taking the derivative of z squared, but with respect to t. So it's going to be 2z dz dt. The only thing different about this situation compared to the ones we've already done is we have this chain rule now in the derivative. But these derivatives should be old hat for you guys at this point, because we've been doing them for so long. So we're trying to find, in this problem, we're trying to find how fast dz dt is changing, the distance between the two ships. So I'm going to try to isolate that. So the way I can easily do that is by divide both sides by 2z and divide this side by 2z. Funny story, my daughter always gets mad at me because I do my 2's two different ways. Look at that. She always gets confused. Which one are you talking about? Why do you do it that way and why do you do it that way? I'm sorry if that's confusing you, so I'll just turn it to be consistent with my 2's. There you go. As you can see, this is goodbye-bye with that, and this is goodbye-bye with that, and we're left with x plus y, the quantity x plus y, times dx dt. I'm not going to put the 1 in there, it's understood, and dy dt equal to dz dt. Now dreads. Remember, diagram we did, the rates that are in there, the equations, the derivative, and now what's S stand for, if you remember? Substitute and solve. So we're going to substitute and solve. So x plus y. We need that x and the y value. Ooh, I'm going to fill in the stuff I do know. I know this is 35, and I know this is 25 based on our rates, and we're looking for dz dt. Yeah, I know. Someone's saying, you forgot to divide by z. There it is. I'm dividing by z. And we have dz dt is what we're looking for. But we need that x plus y, and we need our z. How are we going to get all that stuff? Let's go back a page. We need to know this distance x. Now remember, we're trying to find this. It starts at noon, and we're trying to find it at 4 p.m. So that means these ships have been traveling for 4 hours. So how far could this have gone in 4 hours? That would be right. 35 times 4 is 140. How far has this gone in 4 hours? Well, it's traveling 25 kilometers per hour for 4 hours. I will write it down, but I don't know if you need to see this. It's 100. So we have 100 and we have 140. So the x plus y would be 140 plus 100 equals 240. So we have this side is 240, this side is 100. We can easily find z. So let's go back now. So we know x plus y is 240, and if you don't remember how we got that, or you didn't understand that, sorry, wrong spot, you can go back to rewind the video a little bit and figure it out. Actually, I'll just write it as I won't do the simplification there. 140 plus 100. Now, how do we find z? Well, we find z using the Pythagorean theorem again. So we go in there and we do our 240 as our one side squared plus our 100 squared equals our z squared. And we find out what that value is. You can use your calculator if you need to. If you don't know what 240 squared is, if you heard that, that was my calculator coming out. Alright, second square root of that big number. We get 260. So z is 260. So that's 260 there. Do the math. Find out what that is. And you should find out that when you calculate this, do this arithmetic, and I'll advance it to the next slide, you will find that dz dt, how fast the ships are changing, is 55 to 3 decimal places, 385 kilometers per hour. Now you have to ask yourself, does that make sense that this rate is greater than both of the rates and how they're traveling, one traveling north and one traveling south? Does that make sense that that rate is larger? that is the end of the Pythagorean theorems related rates. There are 4 videos in this series. There is related rates 1, related rates 2, related rates 3, and then 4 to conclude. So I hope you enjoyed these, and now be prepared tomorrow to come in and be ready to go.